What if I told you that a single, invisible force is the reason you stay on the ground? Your coffee cup doesn't float away, and entire planets don't drift off into chaos. It's true, and that invisible force is gravity. But what is gravity really? And how does it manage to hold everything together without us even noticing it's there? Let's dive deep into the secrets of gravity and see how it silently shapes our lives and the universe itself. All right, picture this. You jump up, but no matter how hard you try, you always come back down. That's because Earth is pulling you back. This mysterious force, gravity, exists between anything that has mass. Earth pulls you toward it, but guess what? You also pull Earth toward you. The difference is, Earth is so massive, we don't notice it moving at all. So why do things fall? It all started with a brilliant question. Why does the apple fall from the tree? Back in the 17th century, Isaac Newton asked this very question. Legend has it that he was sitting under an apple tree when an apple fell to the ground. He realized that something must be pulling it down, and he named this force gravity. But he didn't stop there. Newton came up with the universal law of gravitation, which says that any two objects with mass attract each other. The heavier the object, the stronger the pull. That's why Earth, with its enormous mass, pulls you and everything else toward its center. But how does gravity work in space? If the planets are just floating out there, why don't they drift away? Turns out, gravity is the glue that keeps everything in orbit. Earth, for example, is orbiting the sun because the sun's massive gravity keeps it on a tight leash. Imagine swinging a ball on a string. As long as you hold on, the ball circles around you. But if you let go, it flies away. Gravity is like that string, keeping planets from flying off into the dark depths of space. Here's something cool. The strength of gravity depends on two things: mass and distance. The closer two objects are, the stronger the gravitational pull. But as you move farther away, the pull weakens. That's why astronauts on the International Space Station float. They're so far from Earth's surface that the pull is much weaker. Now, they're not totally weightless, but they're in free fall around Earth. Essentially, they're constantly falling toward Earth, but also moving forward fast enough to stay in orbit. This creates that amazing floating effect you see. Gravity doesn't just keep things down, it shapes the Earth itself. Ever wonder why we have tides? Gravity is the answer here too. The moon's gravity pulls on Earth's oceans, causing the water to bulge out in its direction. As Earth rotates, this bulge moves, creating high and low tides. So, even from hundreds of thousands of miles away, the moon's gravity has a powerful effect on us. Let's take it one step deeper. Gravity isn't just about pulling objects, it's actually bending space itself. Einstein's theory of general relativity introduced the idea of space-time. According to Einstein, massive objects like planets and stars bend space-time around them, creating a kind of dent. Smaller objects, like planets, follow these curves, which keeps them in orbit around larger objects. Imagine placing a bowling ball on a trampoline. It creates a dip. Now, if you roll a marble near it, the marble moves along the curve toward the bowling ball. Gravity works in a similar way, except we're talking about the fabric of space itself, bending and shaping how things move. And then, there are black holes, the ultimate gravity monsters. Black holes are formed when massive stars collapse under their own gravity. The result? A region of space with gravity so strong, even light can't escape. Imagine something so powerful that it pulls in everything around it, trapping it in a zone of no return. This is the edge of a black hole, called the event horizon, where anything that crosses it disappears forever. It's gravity, but cranked up to extremes. Gravity doesn't just affect objects, it helps shape entire galaxies and even the universe itself. Massive clusters of stars, planets, and gas are all pulled together by gravity to form galaxies. And then, clusters of galaxies form what scientists call the cosmic web, giving the universe its complex, interconnected structure. If you zoom out far enough, you can see that gravity is like a cosmic architect, organizing everything into this intricate web we call the universe. So, what does all this mean for us down here on Earth? Gravity keeps us grounded, literally. It also affects how we build everything, from skyscrapers to spacecraft. Engineers need to calculate gravitational forces to make sure buildings stand firm and rockets can actually leave Earth. Even sports are impacted by gravity. Think about how gravity affects a soccer ball's trajectory when a player kicks it across the field. Gravity may be invisible, but it's absolutely essential for life as we know it. So, next time you drop your phone or watch the waves roll in, remember that gravity is silently working, holding everything together. It's one of the most powerful, mysterious forces in the universe, and yet, it's woven into our everyday lives. If you enjoyed this breakdown of gravity, don't forget to like, subscribe, and check out our other videos on the forces shaping our world and beyond. Thanks for watching, and we'll see you next time.